Okay, let's jump into a deep dive today. We've got some really fascinating material here. We're looking at a region shaped by these huge forces like ancient geological shifts from millions of years ago, right up to modern political decisions drawing lines on maps.
That's exactly it. And it's not just about the geography, is it? It's where, deep time meets human history, even biblical stories and debates. It's a place where nature has found these, well, astonishing ways to cope with really harsh conditions. And human ingenuity, too, from like the earliest metal workers to the communities living there right now. It's all left its mark.
Absolutely. So our mission here is to pull out the most interesting bits, the surprising insights from this material you've gathered. We're going to cover like weird border changes, plants with these unbelievable survival tricks,
Uh-huh.
the very beginning of humans making metal from rock, and oh yeah, these incredible journeys millions of birds take every year.
Yeah, you'll see how something like the rock formed, half a billion years ago can actually influence where a tiny bird lands today. It's pretty amazing.
Wow. Okay, so let's start with those borders, those lines on the map,
Sure.
because, like you said, they weren't always where they are now. The material mentions the British Mandate, the establishment of Israel, key moments for the modern boundaries.
And there's this one really specific, kind of weird example between Jordan and Saudi Arabia back in 1965. Basically, Jordan wanted more coastline near Aqaba. They didn't have much. Saudi Arabia, meanwhile, had tons of inland desert.
Right, so they swapped land.
They did. Jordan gave up some inland territory, and Saudi Arabia gave Jordan a stretch of coast. Jordan's border along there went from, what, about 6 kilometers up to 25.
Okay, sounds reasonable, but there was a catch, wasn't there?
Well, the stated reason from the Saudis for wanting that specific bit of inland desert, they said they thought there were water springs. Good for their nomadic tribes, pleading their circuits.
Seems plausible.
But here's the part that makes you go, the exchange rate. It wasn't 1-to-1. For every 1 square kilometer, the Saudis gave Jordan on the coast. Jordan gave Saudi Arabia 5 square kilometers inland.
5 to 1. Wow. That's quite a preaching for coastline. Like the material says nothing comes for free.
Definitely not. It really shows how these lines get drawn based on needs, perceptions, maybe even leverage. And you see it on a smaller scale, too, like that story about Taba, right on the border with Israel.
Oh yeah, tell us about that.
So back in 1906, drawing the border, the local Ottoman governor, Rushdie something, he apparently ignored orders. He didn't want the borderline cutting through Akaba itself because he wanted his town out of range of British artillery.
Artillery range, seriously.
Yeah, about 11 kilometers back then. So because of that, the border got shifted slightly south to Taba. A governor's worry changed the map.
That's incredible. A single person's concern shaping a national boundary. Okay, so Akaba itself, the port. The material points out something surprising. Its size. It can apparently handle more cargo tonnage than Israel's main ports, Ashdod and Haifa, put together.
Which is kind of strange, right? Why would a country with a, much smaller GDP need such a massive port?
What's the story there?
History. It goes back to the Iraq-Iran war. The Straits of Hormuz were blocked, so ships couldn't get to Iraq directly. Aqaba became the main entry point for goods heading to Iraq, a lifeline.
Ah, okay, that makes sense. And now?
Now, the material says it's mostly underused, a huge piece of infrastructure left over from a past conflict.
Fascinating legacy. All right, let's shift from those human lines to the deep structure. The geology, you mentioned it's really visible here.
Oh, definitely. You can almost think of the region's foundation like a 3-layered cake.
A geological cake. Okay, I like that. What are the layers?
So the bottom layer, the oldest, is igneous or magmatic rock, formed deep underground from cooled magma. Really ancient stuff, like 600 million years old in places.
Wow. 600 million years. Okay, that's the base. What's next?
Middle layer is continental sandstone, about 520 million years old. This tells the story of a totally different time, huge, wide rivers depositing sand everywhere.
Rivers bigger than anything we know today, probably.
Yeah.
Half a billion years ago. It's hard to even picture. And the top layer.
That's marine sedimentary rock, much younger, maybe 100 million years old. So after the rivers, the whole area was actually under an ancient sea for a long time.
Under rivers, then under the sea.
Yeah.
All on top of that ancient base. How do you actually see all this history in the landscape today?
Well, you look for the faults, the breaks.
Yeah.
You see layers that are out of order, different ages side by side. You see tilted layers, rock that should be flat, pushed up at steep angles, maybe 45 degrees. And rivers, they often follow the path of least resistance, which means they carve their beds right along these fault lines. They expose the breaks.
So the riverbeds are like clues tracing the hidden cracks. The material also talks about dikes.
Yes, dikes are where magma pushed up through the existing layers and solidified. Some are harder than the rock around them. Those are positive dikes. Erosion wears away the softer rock, leaving these like stone walls sticking out of the landscape.
Like natural walls.
Exactly. And then negative dikes are softer. They erode faster, leaving behind these long, narrow gullies or sometimes almost tunnel-like features.
And that boundary, the line where the really old igneous rock meets the younger sandstone.
That's called the peneplain. It's basically a surface that got leveled off before the sandstone was deposited. You can often see it as a distinct line in the cliffs, a meeting point between those two huge geological chapters.
Amazing how you can read the earth like that. Okay, from the deep earth to life, starting with the Red Sea, the Gulf of Aqaba. There's a world record mentioned.
Yes, it's the northernmost coral reef system in the world.
Northernmost? That sounds wrong. Aren't reefs tropical near the equator?
Usually, yes. That's what makes this one so unusual. It's really far north for such a rich reef. And despite that, it's incredibly diverse, like 1,000 species of fish, 250 species of coral. Just amazing for where it is.
How does it manage that?
Well, adaptability is key. The material mentions soft corals, for instance. They don't rely on sunlight like hard corals do through photosynthesis. They use chemosynthesis, getting energy from chemicals in the water.
Another survival strategy. What about bigger stuff? Sharks.
They're there, apparently, but very rarely seen. There's an anecdote in the material. Someone swam there daily for 28 years and only saw one shark.
One shark in 28 years. Okay, maybe not something to worry about too much then.
Seems that way. And it's interesting, the material also mentions locals swimming daily, cleaning the beaches. Sounds like a strong connection to that unique environment.
Definitely. Okay, let's move inland to the desert proper. The challenges there are, well, obvious. Water.
Oh, absolutely. Water, or H2O, is the #1 limiting factor. Rainfall is incredibly low. Eilat gets maybe 20 millimeters a year. Compare that to like 200 millimeters, which is often considered desert threshold. And evaporation is massive, constant.
So barely any rain, and it vanishes instantly. How do plants even survive? I liked that fight or flight idea from the material.
It's a great framework. Plants either sort of flee the problem, avoid the worst conditions, or they fight it with special adaptations. Flight often means being an annual, living just 1 year, pouring all energy into seeds, and then those seeds just wait, sometimes for decades, waiting for enough rain.
Decades! Just sitting there as seeds.
Yeah, something like 70% of the plants in these really extreme desert areas are annuals, just waiting.
Incredible patience. What's another flight method?
Bulbs. Think of desert irises. The plant only pops up when conditions are good, but the bulb underground stores everything that's following. The DNA, the energy, sometimes for years, just weathering the drought.
Okay, so that's avoiding the problem. What about fighting it? Staying active year-round.
The main enemy, besides lack of water, is salt. It's everywhere in the soil, and it's lethal to plant cells, so they have to fight the salt. One way is dilution. The Zucchini plant, for example, takes in salty water, but manages to keep the salt concentration inside its tissues relatively low, less damaging.
So it waters it down internally. What's the other way?
Get rid of it. Actively pump it out. The ashel plant does this. It invests energy to push salt ions out, often through its leaves. The material says if you were to taste an ashel leaf, it would actually taste salty.
Wow, a plant literally sweating salt. What about saving water, stopping evaporation?
That's a huge battle, too. One tactic is reducing surface area. The Figonia plant just drops its leaves entirely during the hot, dry summer. Less surface, less water loss.
Makes sense. Simple but effective.
Others develop a thick, waxy coating, a cuticle. The caper plant is a good example. If you rub its leaf, you can feel that waxiness. It seals the water in. And the caper has another cool trick on super hot days. It can turn its leaves so the narrow edge faces the sun. Less direct exposure.
Like tiny solar panels adjusting themselves. Amazing. And there was one plant helping out insects.
Yeah, the Atad plant. Really clever. Its flowers start off violet. That's the signal to pollinators. Come here, I need pollinating. But once a flower is pollinated, it changes color to white.
Ah, so it's like putting up a "sorry, I'm done" sign for the bees.
Exactly. It saves the insect wasting time on a flower that's already set and ensures the plant's energy goes towards attracting pollinators to the flowers that still need it. Super efficient. It's also apparently very thorny.
Fascinating adaptations. Okay, let's switch back to people, but way back in time. Archaeology. The material talks about ancient groups like the Midianites and Edomites living in this desert area, part of the wider Sinai region.
Right. And for these groups in the specific place, we don't have many written records, so archaeology is crucial. But it can be tough. The pottery they find is often pretty basic, locally made. not easily identifiable. Sometimes archaeologists label it Midianite as a best guess based on context. It's different from finds in other parts of the Negev where you might get, say, Judahite pottery.
And there are links to biblical figures mentioned. Jethro, Moses' father-in-law, a Midianite priest.
Yes, and that brings up that whole ongoing discussion in academia, the historicity of the biblical stories themselves versus the archaeological job of identifying the places mentioned. While the stories are debated, many locations from the Exodus route, like Kadesh Barnea, seem to have solid archaeological counterparts.
But other big ones, like Mount Sinai, are still very much debated. Different mountains proposed.
Exactly. St. Catherine, Har Karkam, multiple candidates, lots of debate. It's also interesting that desert sites often seem to tell stories of people on the fringes or running away. Think of David hiding out in Gedi. These remote places served a purpose.
Makes sense. The material briefly mentions Yatvada, too.
Yeah, listed as a stop in the Bible. Now, it's a kibbutz famous for dairy, but there's a recently excavated Roman fort there, which might even be sitting on top of an older biblical era site. And another place called Irar is mentioned as a stop, too.
But the really big archaeological focus seems to be Timna Valley, described as like a workshop for a huge human step forward.
Definitely, and that step was copper production.
Right. Gold, you can find nuggets of it, but copper was the first metal people figured out how to make by chemically changing rock.
Exactly, transforming it with heat. And Timna is like ground zero for seeing how they learned to do that. It's full of evidence.
So where did they actually get the copper ore from around there?
It shows up in a few places geologically. Tiny bits and cracks in that old igneous rock from hydrothermal vents, but not really usable. Some deposits in the marine sedimentary layer, possibly linked to ancient algae that absorbed copper. But the main source, the stuff they were really mining extensively, was in those sandstone layers.
And Timna shows the learning curve, how they got better at smelting it, getting the pure copper out.
Oh, absolutely. You can see the progress. It's like evidence of early scientific investigation, trial and error. They've analyzed the slag the waste material left after smelting. Slag from around the 14th century BCE shows they were getting about 98% of the copper out of the ore.
Which sounds pretty good already.
It is. But slag from just 200 years later, the 12th century BCE, shows 99.6% separation.
Wow, quite a jump. So they were refining the process, maybe adding other minerals.
Exactly. The material suggests they might have learned to add things like manganese or iron oxide as a flux, maybe control the heat better. They used tools called tuyeres, basically tubes, maybe reeds with clay or tin ends, to blow air into the furnaces, get the fire hot enough.
Simple tech, huge results. And this wasn't just a small local operation, was it? This copper traveled.
Oh yeah, big time. The material mentions Timna copper being found 700 kilometers away in Luxor, Egypt, south of Cairo.
700 kilometers, the effort involved.
It's immense. The estimate mentioned is something like 10 hours of hard labor might produce only 5 kilograms of copper. So hauling enough for tools, weapons, statues, all the way to Egypt. It shows how incredibly valuable this metal was.
Timna also has that temple site, right? The one with the debates around it, used by Egyptians and Midianites.
Yes, initially used by both, apparently around the same time. Then the Egyptians left, but the Midianites stayed and seemed to have defaced the Egyptian carvings and adapted the temple for their own use. And this site became central to a famous archaeological argument.
The whole Solomon's Pillars thing.
Exactly that. Nelson Glueck, excavating in the 30s, saw these impressive natural sandstone pillars in the valley. He believed King Solomon ran the whole mining operation, so he named them Solomon's Pillars. So Solomon is the, CEO of ancient Timna copper mining.
But later archaeologists questioned that.
They did. Benno Rothenberg came along later and argued, look, there's no direct proof linking this site to Solomon. The biblical accounts are different. Some artifacts seem older, maybe 300 years before Solomon's time.
And then even more recent work.
Yeah, Ari Ben Yosef's research, using newer dating methods, actually found evidence of significant mining activity during the 10th century BCE, which is the time of Solomon. But crucially, that still doesn't prove Solomon himself was directing operations here. It just means large-scale mining was happening then. So the picture is still kind of complex.
And the material makes a really specific point about the evidence at that temple site itself.
Yes, this is important. It stresses the lack of clear Jewish evidence found at the temple. While things like pig bones might be discussed in relation to other sites in the region sometimes, the key point here is the lack of positive evidence linking this specific temple to Jewish worship, whereas the Midianite connection, especially after the Egyptians left, is much clearer archaeologically. So despite the catchy name, Solomon's Pillars, the actual evidence from the temple points strongly towards it being a Midianite place of worship.
That's a really key distinction. The name tells one story, the archaeology perhaps another, more specific one for that spot.
Hmm.
And the name Timna for the valley itself, that wasn't even related to a biblical Timna.
Correct. That name was given by a modern Israeli committee in 1949, completely separate from any biblical Timna mentioned in Genesis or the Samson stories, whose locations are debated anyway. And as a bit of trivia, they named other nearby spots after Job's friends Eliphaz, Zophar, Bildad.
Huh, that's quite a theme. Okay, one last point on Timna. The workers. Slaves or not.
Another debate. Gluck thought they were slaves. Reasons. The work looked incredibly hard. His view of ancient social structures was kind of rigid, master-slave, and he found a wall he interpreted as a prison wall.
But Rothenberg and others pushed back.
Yes, they argued the work, while hard, could be done in cooler periods, that skilled craftspeople, like smelters, weren't necessarily slaves, that maybe the master-slave model applied more to service roles, and the wall. Its purpose wasn't definitively proven to be a prison. So the reality was probably more complicated than just slaves doing all the hard labor.
Okay, let's fast forward again. Contemporary life. What's it like living in this region today, surrounded by all this history and extreme nature?
Well, the material paints a picture of some agriculture mixed with possibilities for tourism, like retreat centers, that kind of thing.
But farming sounds really tough there.
It does. Big challenges. Competition from cheaper imports is huge. Tomatoes, peppers, olive oil, especially from places like Spain and Greece. Plus, production costs are high. Labor costs money and water. Well, water is obviously expensive and scarce.
And bureaucracy.
Yeah, that's another layer. Farmers might have to deal with regulations from like 5 different government ministries. So all that competition, costs, red tape, it's leading to fewer family farms. The trend is towards larger companies renting the land or bigger operations taking over.
Infrastructure costs going up too, less support.
Exactly. And there's this weird cost of living thing. Housing might be cheaper than in the big cities, but everything else is expensive because it has to be trucked in. And getting services can be slow, like waiting weeks for a plumber or electrician.
Weeks for a repair. Ouch. That would be frustrating. The material also mentioned a specific community, Ovat.
Ah, yes, Ova, founded by a man named Simcha Perlmutt, who identified as a Messianic Jew, apparently based on a vision he had. It became a place that attracted international volunteers through an organization called Desert Blossom.
And the Von Trapp connection.
Right. Apparently, one of the daughters of the actual Von Trapp family from The Sound of Music, the one born later in America, volunteered there for a time. Just a little unexpected intersection of histories.
Definitely unexpected. Okay, finally, let's look up. The sky highways, bird migration. This region is massively important for that, isn't it?
Hugely important. It's an incredible process for the birds. Before they even think about flying south, they have to molt replace all their feathers with fresh ones, perfectly suited for a long-haul flight.
Oh.
That takes time, maybe 1.5 to 2 months for a young bird.
Like getting a whole new flight suit and then fueling up.
Oh, yeah. Fat storage is everything. Their metabolism goes into overdrive. The material mentions they can potentially double their body weight in just 5 days of intense feeding.
Double their weight in 5 days, that's just mind-boggling.
And it's not just pure instinct driving them. There's decision-making involved. A bird needs perhaps a kind of courage or optimism to leave a place with food and head towards the uncertainty of Africa.
How do most of them travel? We picture big flocks, but...
For the majority, maybe 80–90% of the small migratory birds like warblers, it's different. They fly mainly at night, often alone, not in big V formations, and quite silently over this area, navigating by the stars.
Night flight makes sense for avoiding heat during intense exercise. Why else fly at night?
Cooler temperatures are a big factor for that kind of aerobic effort. Also, fewer predators, like hawks, are active at night. And yeah, navigation using the stars is key for many species.
And Eilat's location is critical in this.
Absolutely critical. It acts as a major bottleneck geographically. But more than that, for many species, it's the last stopover site, the last chance to refuel before they face the Sahara Desert.
A Sahara. That sounds like an impossible barrier for a tiny bird.
It's immense. We're talking 3,000 kilometers of essentially foodless desert for a bird that usually lives in forests or eats insects. No stopping points.
So Eilat is make or break.
Pretty much. They have to store enough fat reserves in and around Eilat to fly non-stop across the entire Sahara. That could be a continuous flight of, say, 3 days and nights.
3 days, non-stop, powered by fat they gained around Eilat. That is just an unbelievable feat of endurance.
It really
Yeah.
is.
Yeah.
And these stopover sites along the way, these green lines of migration, they're vital. Different birds need different gas stations, places with algae for ducks, insects and berries for warblers, fish for
Well,
herons.
whole complex aerial support system intersecting right here.
Exactly.
Wow. Okay, we've covered a huge amount of ground and time from, geology millions of years old shaping the land
Uh,
to life finding these incredible ways to survive in the desert and the sea,
uh.
ancient people learning to make metal, and now millions of birds using this place as a crucial waypoint.
And what's really striking is how it all connects, isn't it?
Mm-hmm.
The deep geology, the faults, the rock types, it dictates where water might be, which shapes plant life, which influence where humans could settle and mine. And it even creates the physical funnel that channels those migrating birds,
Hmm.
making this area their last vital stop before
Yeah.
the Sahara.
So this place, which you might just think of as, empty desert and a bit of coast,
Yeah.
it turns out to be this pivot point, crucial for early human technology with the copper, and crucial for this massive ongoing cycle of global life with the bird migration.
It really makes you think about how things we see as separate geology, climate, animal behavior, human history, technology are all tangled up together, operating across these vast scales of time and space, shaping a place and everything that passes through it.
Definitely gives you something to ponder next time you look at a desert map or just see birds flying overhead in autumn. What other deep, hidden connections are right there in front of us?